Well, I've got a job to install a keypad system, and there's an existing intercom in the building that also buzzes the strike, and that wiring is kind of across the hall in a dusty bin. It hasn't been touched in a million years, and I just want to leave it alone. So I'm using an Essex K134S keypad, and normally I would run that in this configuration here using an electronics relay board. So the trigger signal from the keypad activates, the coil and switches the contacts and sends the positive through to the strike. And that's what I would normally do, but in this case I have two wires with unknown 24 volts, AC or DC, something coming through from when people in the units push their button to let people into the building. So I built up this cool little project box with a couple boards, and we're gonna break the two powers separate from each other, but still have the strike energized using both systems with no worries of somebody entering a code on a keypad simultaneously as somebody pushing a button in a unit and frying things up. So, I've kind of pre-wired and got this thing all ready to go together. But I got this RBST relay board from Altronics, and when it gets voltage across these two, it trips one of these two sets from normally closed, normally open, normally closed, back and forth between a common. And I'm not even using this side really other than to trigger the solenoid with power. And I'm just using these positive outs to kind of complete the circuit to the strike. And so I have a lower board, which is for the intercom unit. That's what this one is. And then the upper board is basically what I would call the main board, the keypad board. And so I'm using these Lightion PBL302 rectifiers, 4 amps capable, and kind of bent the leads to work with the relay boards. So brought my positive over. I've got everything designed to drop right in there for the two terminals. And essentially the intercom wires are gonna, in the field, I'm gonna connect this bullet connector onto those two. So the old intercom wires that powered the door previously are gonna send their voltage into this rectifier. It'll change it from AC to DC. And I threw a little capacitor in there to add some filtering. And it was kind of built in place and positioned. I bent the sturdy leads of this rectifier to line up with and drop into this unit here. So my capacitor ended up upside down, nestled between the coil and the rectifier, and ending up below flush with the terminals standoffs. So we're good there to stack. So these two are going to build together. With their terminals. And that way who knows, presumably AC voltage is going to go in these two greens and feed the rectifier, converting it to DC to trip the coil, which is a DC board, so I need to send DC power to this. And when the intercom board, gets signaled with its power, it's just going to energize the coil, and all it's doing is closing these two. This is a common that's basically going to have, voltage present, so to speak, on contact, with the closure of the coil, and complete the circuit over to this one, which is normally open, which would close at that time. And this just lets the positive through to the strike and activates the system. But these are actually jumpers. They're going up to our board above, and we're going to use what's normally our outs up there and just kind of parallel these on top to trigger the top board and power the strike. So we're just using the bottom relay board as a switch. So when it gets power, it switches these two so the current can flow through just as it would here. When this coil's activated, it can also trigger those. So I'm just gonna put these all together, and this will piggyback to the top of the board from below. And here I did a similar thing, another rectifier with a capacitor tied in, and similar concept. I had a little more headroom, so I went ahead and just stood the rectifier up, running the positive lead, around that first terminal, and the negative didn't need to run to the negative side because there's a negative input trigger that'll be coming from the keypad itself. To this terminal here, once I'm in the field, so the keypad will send power here, and it's already got this power over here, and it'll trip these contacts. So these boards already had a hole in them. I went ahead and electrical taped the back. It doesn't seem like any terminals are touching the board below, but they're going to stack in here. And I got this handy box, and I positioned the boards in the box, used the existing hole in the board and drilled the pilot hole through the back of the box, and I got this nylon screw just poking that in from behind, and the boards kind of hang on that. So the bottom board is the flush board, the intercom board, and I have not yet cut one of these two jumpers here, J1 and J2, and it says cut J1 for 24 volts, cut J2 for 12 volts, so I've got 24 volts going on that system there. So we're just going to cut that jumper, move it aside a little bit, leave it partially connected, and put this in the box. So these are our feed to the old intercom, from the old intercom power to the greens. Right down in there. We're on a nylon post. I'm all the way down against the bottom here. And the top board should go on. And those jumpers connect. In these positions. So we're gonna get, I think we'll bring this one around and take it from the top. I guess do they mesh? I guess bring them from opposing sides. At least on this one. Kind of share that hole. This one. Come on, little booger. I had hopes of coming from the other side with it. I probably just need to move this jumper that way. So this will get a spin. Sorry, I'm taking up everything. Everything of your time is being taken. But I think it's going to go together good. Damn it. That little bitch. Success. I'm going to make sure I pull this relay all out of that hook onto that screw. And that's why I figured I'd build this up before it's upside down on the ceiling, which is what's going to happen. I put this nylon bushing out the back here. I'll push that up, run a wire from upstairs, keypad wire, and extract wires and whatever. A couple cables down through there. And then power from the ceiling. There's a wall plug on the ceiling or whatever, and it's going to just run 2 conductor in here to bring my AC in for the strike and keypad system. Because I'm just running an AC plug-in transformer that's cheap and powerful and reliable. Converting it to DC myself with these rectifiers. Throwing in some capacitor filters, so that's cool. But now that I've got my jumper plan going, I just reversed that jumper. There's a jumper that goes from the positive, which is hot right off that rectifier, over to the common that's going to switch the electric strike. That's basically waiting to send to the strike, and when the coil closes, the switch will close and it will send from here to there, and from there it goes to the strike, I believe, which is this other cable that I've got coming in this way, which is going to happen on the job site. But we'll put it together for now. Oh, I know, I'm sorry about this. I'm using a pan of ice to hold the circuit board vise to hold the phone. And we got them, so that'll eventually be destined for the on the job, going to the power of the strike. Which I had all the new system drawn out here too, if you wanted to see that. It's not the greatest drawing, but these are the 2 boards. This is the rectifier. This is the intercom board, the lower board, and I just drew the rectifier to the side. I just need to figure out how to wire it. So this board had a rectifier. There was the existing output from the intercom coming down in here, feeding the rectifier, right? And then I took the positive to the its contact and the negative to its contact and whatever. Do the strike in there, the power supply, the original board, which is styled basically using the same wiring diagram as I normally use for the Sargent Essex K134S. And this is where I mapped it out. And this is the build, so the build is more fun than mapping it out. So everything down here is never gonna be accessed again, so we'll make sure we're all tight. And I got a real humid environment down in this basement where this is gonna go. So I got this sturdy box with the seal. Basically that board just sits on top of the other board down in there. on the same little pin. And then what I was going to do, I don't know if I've lost it, but somewhere I have a blue wire nut. I'll just take a wire nut and screw it onto the nylon post of that screw there. You know, the boards can't really fall out anyway. It's not really going anywhere, but I was capping it with the same kind of nut as this, which is just, this is a pre-made twisty wire where I'm going to bring 2 or 3 things together there for this negative supply. But put this little wire nut on top of that nylon screw down there to hold it all in place. And it'll be an extra wire nut for if the guy ever loses this one. So, put a little zip tie tab down there because I'll be bringing power in. Maybe I'll get a thinner zip and zip the power cable right to the back of this box on the way in. And then I can go through it the other way or second time or whatever if I want to try and tidy up anything else. Maybe sometimes I'll create a ring, like just a zip tie ring that's loose and not zipped down tight, and then you can hook other zip ties on that. But we'll be bringing the intercom power when the tenants push the old system buttons in here, triggering that lower board, sending the power up to the top board, going across the 2 outs that would normally get completed if the top was being energized by the keypad system. And then the connections on the job are those 2 ends from the old intercom through bullet connectors, and then this is the keypad violet. There's a violet wire on a keypad harness, and it converts to another color by the time it gets down to this box, but this is basically what I call keypad violet. And keypad red is gonna have a ring and terminate on top of this, I believe. And these are my AC ends from my plug-in transformer of my system that's going to power everything through these bullet connectors. Come through the hole, zip tie to that. Bam, my power goes in there. You know, their power was going to show up if it has to. The 2 boards will keep it independent in operation so our power systems aren't linked between both buildings. And that is it. This black wire goes to the keypad black, negative power for the keypad, and it also needs to go to the negative of the electric strike. So the electric strike negative is always hot, waiting for the closure, and then when the closure happens, positive makes connection and it's a go. I made notes on the inside of the lid just so that I remember how everything's wired up and what the deal is. That might help me or somebody else out in the future while I'm thinking about it. So this job can go together. It'd be the secret in the basement.